Hello, my name is Professor Gilbert Byron. Gil's fine. How are you? This is HVAC 101, and this is the first of several slideshows that we'll use online to help you with learning the basics of the HVAC industry. This first slideshow will deal with heat transfer, pressures, basically it's the basis of the HVAC industry. Okay, so let's get started. The law of the conservation of energy states that energy cannot be destroyed or created. It can only be changed from one form to another or transferred. In the diagram, you can see how the different types of energy are transferred or transformed. Take a few minutes and study the slide. Heat is a form of energy that is caused by the movement of atoms and molecules in a substance. Heat transfer occurs when the atoms and molecules collide. When molecules collide, some of the energy from the faster moving molecule is transferred to the slowing moving molecule. Heat transfer only occurs from warm to cold. An example of this is when you're in a supermarket and near the refrigeration cases, you feel cold. What you're actually feeling is the heat from your body moving to the cold refrigeration cabinets. We use the words hot and cold to describe temperature. When finding the temperature, you're only finding the heat intensity. What is important to understand that you are not finding out how much heat something has. You're only finding out how hot or cold it is. The two most common temperature scales used in the HVAC industry are the Fahrenheit scale and the Celsius scale. They are based on the melting of ice and the boiling of water at sea level. It is important that you are able to convert between the two scales. If in the picture of thermometers they were to show all the hash marks between the temperature ice melts and water boils, the Fahrenheit thermometer would have 180, while the Celsius would only have 100. So for 5 marks on the Celsius scale, you have 9 on the Fahrenheit scale. The Fahrenheit scale is predominantly used in the U.S. If you have to work on HVAC equipment manufactured outside of the U.S., it is important to have the formula to convert from degrees Celsius to degrees Fahrenheit and vice versa. Take a few minutes by pausing the video and attempt the example. Don't forget the math order of operations. You have to solve what's in the parentheses first. Lastly, these scales are used to measure the heat intensity of an object. Let's not forget that. It's a very important concept. It's the intensity of the object, not how much heat the object contains. When talking about how much heat energy something contains, we measure the amount in BTUs. BTUs is short for British thermal units. The definition of a BTU is the amount of heat needed to raise 1 pound of water 1 degree Fahrenheit. An example of the amount of heat energy as opposed to the temperature of something, you can look at a kitchen match. It contains approximately 1 BTU of heat energy. But when you light that match, its temperature, the intensity of it, is anywhere from 1100 degrees to 1500 degrees. So that's a very high intensity, but very low heat content. When finding the amount of heat in a substance, what we are doing is calculating how much heat was added or removed to bring the substance to its final temperature. The formula for finding the amount of BTUs that are transferred is to multiply the specific heat capacity of the substance by the mass, which is its weight, and by the temperature change of the substance. All substances have a specific heat capacity. The definition of specific heat is the amount of heat required to change 1 pound of a substance 1 degree Fahrenheit. The specific heat capacity is about a specific substance. It takes 1 BTU to change the temperature of 1 pound of water 1 degree Fahrenheit. So its specific heat capacity is 1. The specific heat of iron is 0.129 BTUs per pound, which is way less than water. To change the temperature of iron 1 degree Fahrenheit, you need to add or remove 0.129 BTUs per pound. If you notice in the formula, there is a triangle with a T after it. That is what we call the delta T. The delta T means the difference in temperature. When applying the formula, before you can multiply by the delta T, you have to first subtract the initial or beginning temperature from the final temperature. So basically what you started with and what you end up with. Please take a few minutes and attempt the problems at the bottom of the slide. Please, and what I'll do is on the following slide, I'll have the answers written out. So take a few minutes to try it on your own and then check my answer. Okay? So as you can see, it takes 300 BTUs of heat energy, either added or taken away, to change 10 pounds of water 30 degrees Fahrenheit, due to the fact that specific heat of water is 1. Whereas for iron it's much lower, due to the fact that its specific heat is 0.129. Heat transfer occurs 3 ways, either by convection, conduction, or radiation. Conduction is the flow of heat through a solid or between two objects touching. In the picture we have a pan sitting on a hot stove element. Since the pan bottom is cooler than the hot element, heat energy is going to be transferred from the stove element to the pan by conduction. Don't forget, heat always travels from hot to cold. Since the pan is a solid, the heat is going to transfer from the bottom of the pan to the inside, where the bacon is. And at that point, heat is going to transfer to the bacon by conduction, because the pan and the bacon are touching. I do love bacon. Convection is the flow of heat through the motion of molecules in a fluid. A fluid can be either a gas or a liquid. So as an example, air and water are considered fluids. How it works is as the gas or liquid is heated, it becomes less dense and rises to the top. The cooler, more dense gas or liquid then falls and gets heated. Then that rises again, and at that point you form a convective loop. An example of this is if you're heating the air in a room, the hot air will rise to the top of the ceiling, and the colder air will tend to float back down to the bottom on the floor. Radiation is a transfer of heat by electromagnetic waves. Light, microwaves, X-rays, TV, and radio waves are all kinds of electromagnetic waves. When the electromagnetic waves encounter an object, it transfers heat energy to that object. Electromagnetic waves will only move in a straight line. Looking at the picture, you see how the waves are depicted as straight lines. It is because they will not curve around an object. Think about the sun and the earth. Only the part of the earth that is facing the sun receives the light. The other side is the earth is dark. So the light side is nice and warm and the dark side is cold. Substances exist in 3 states: solid, liquid, and gas. Which state a substance is in is dependent upon the temperature, pressure, and heat content of that substance. At atmospheric pressure, water remains a liquid from 32 degrees Fahrenheit to 212 degrees Fahrenheit. Below 32 degrees Fahrenheit, it becomes a solid. It freezes to ice. Above 212 degrees Fahrenheit, it becomes a vapor or gas. It boils and becomes steam. During heat transfer, heat is either being added or removed from a substance. When adding or removing heat and there is a change in temperature but no change in state, this is called sensible heat. Remember this term, it is a very important term in our field. When adding and removing heat and there is no change in temperature but there is a change in state of the substance, it is called latent heat. Once again, that is a very important term. The graph depicts how much heat is transferred to a pound of water at different temperatures and the different states the water is in. When the water is in the solid form, ice, it takes 16 BTUs of sensible heat to raise its temperature from 0 to 32 degrees Fahrenheit. At 32 degrees Fahrenheit, it takes an additional 144 BTUs of latent heat to melt the ice and turn it into water. An additional 180 BTUs of sensible heat is added to raise the temperature to its boiling point, 212 degrees Fahrenheit. Now this is important. It takes an additional 970 BTUs of latent heat to change the water to a vapor, which is steam. Temperature, pressure, and volume are all related. Temperature and pressure are directly proportional to each other. What that means is if the temperature increases, so does the pressure. If the temperature decreases, the pressure will decrease also. Pressure and volume are inversely proportional to each other. What that means is if the pressure decreases, the volume increases. And if the pressure increases, the volume decreases. Volume and temperature are also related. Just as temperature and pressure are directly proportional, so too are volume and temperature. If the volume increases, the temperature increases. And if the volume decreases, the temperature decreases. Please take a few minutes and study the slide. The end.